Hey guys, we're going to be working with modeling trig functions, aka word problems. Yay! So our goal is with word problems is that we're going to interpret what they're giving us into information to write those trig equations. Okay? So here we go. An average seated adult, breathes in and out every 4 seconds. The average minimum amount of air is 0.08. And the maximum amount of air in the lungs is 0.82. Suppose the lungs have a minimum amount of air at time equals 0, where t is the time in seconds. Okay, so suppose the lungs are at the minimum amount. So we're down here. And so once you exhale, after you exhale, you're going to start breathing. So your lungs are going to fill up, and then they come back down. Okay? Now we're just going to go back to this first sentence. This all happens in 4 seconds. Okay. Now, why do we need to graph? If I didn't graph, we couldn't tell what type of trig function we're in. And as you can tell, we're in cosine, and it's flipped. Okay. 4 is our period. So we're going to change that into a B. Good cover. Is 2 pi over PD. So 2 pi over 4 reduced is pi over 2. There's our B value. Now, we need to figure out what is midway on this graph. So what is the middle between 0.82 and 0.08? Now, it's like taking an average, 0.82 plus 0.08 divided by 2. And you should get 0.45. And this is our midline. So our midline is 0.45. Now, the next question is, how far away is 0.82 from 0.45? Again, or you can say from 0.45 to 0.08. Now, to do this, all you're going to do is do 0.82 minus 0.45, and we get 0.37. And if you're not sure you did it right, you can do this down here, 0.45 minus 0.08, and you get 0.37. So that means my amplitude is 0.37. Okay. Now let's write our equation. So y equals, it is flipped, so negative amplitude cosine. Oh, and I just thought, phase shift, C. They did not talk about phase shift, so remember, no phase shift equals no C. Okay. Pi over 2 theta. You can put that in parentheses if you like. Do you have to? No. And my midline is plus 0.45. Okay, so there's our equation. Here it says determine the amount of air in the lungs at 5.5 seconds. So we're going to plug this in. Now I use theta. We could have used a t here. I'm keeping it theta. That way we're not flip-flopping. But please know theta and t are going to be the same variable for us. So the way we're going to put this in the equation, or in our calculator, cosine, and I'm going to write it out how you would type it. So pi divided by 2 times 5.5, close parentheses, plus 0.45. So let me get a calculator. Please make sure, I don't know if you can see this, we're in radians, okay? So negative 0.37 cosine pi is right here for me. Pi divided by 2 times 5.5 plus 0.45. And that is definitely not correct. That's way too big. And I see what I did. I forgot my decimal on 37. So negative 0.37 cosine pi divided by 2 times 5.5, close parentheses, plus 0.71. Okay. So remember, the highest amount of oxygen is 0.82. And would you agree my first answer, 266, was a little too much? So we want to be careful there. Okay, next example. A dolphin swims along by the side of a cruise ship. He jumps to a height of 4 meters. I'm so sorry. Above the water surface and dives to a depth of 4 meters below the surface. Okay, so here we go. There's my water. And from what this says, the dolphin jumps 4 feet or meters, 4 meters in the air, and goes down 4 meters below the surface. It also says he jumps first. So what we're going to do is he's going to jump and then go back into the water, right? And then he's going to make the same motion underneath before we start again. That's what this means, regular motion. So it means we're just going to keep diving and coming back up. A passenger uses a stopwatch and starting as the dolphin is at the surface determines the dolphin completes this in 8 seconds. Okay. What trig function are we at? So we have a nice pretty sine curve. What is my amplitude? What do you think my amplitude is? If you said 4, that is correct. I'm going to do this over here. Okay, midline. What do you think my midline is going to be? And the answer is 0. We're going to use the ocean surface as 0.0, so my midline is 0. We got to find our b value because this is our period. So b equals 2 pi over 8. So that reduces to pi over 4. No phase shift was provided, so we don't have to worry. So our equation, y equals 4. And they didn't say, they said he's coming out of the water when he started the jump. That's why we're going to draw it like this. Sine pi over 4 theta. There's no midline and there's no c, so we're done. Okay. So after 3 seconds, so we're going to plug 3 in for theta. So y equals 4 sine pi, and I was going to do it this way, divide by 4 times 3. Okay. You put that into your calculator. 4 sine pi divided by 4 times 3. I get 2.83. Okay. So, and it makes sense. If the whole thing takes 8 seconds, we can assume roughly this is at the 4-second mark. He would still be above water somewhere over here. Okay. Here we're going to let 37 seconds be our time. And the question is the dolphin above or below the surface? So let's first just plug this in. Pi divided by 4 times 37. Okay. So 4 sine pi divided by 4 times 37. And you see, we get a negative value. Okay, so roughly negative 2.83. And the question is, first off, is that okay? And the answer is yes, because remember this is 0. Does that mean he's above the water or is he below? And because it's negative, he's going to be below the surface. So he's going to be 2.83 meters below the surface. Okay. I hope this helps. I will see you in the next video.